The fastest car in the world can reach over 300 miles per hour. The fastest train in the world can travel close to 400 miles per hour. But right now, you, yes you, are moving even faster than any of them. You are spinning with Earth through space at roughly 1000 miles per hour. Yet, you don't feel a thing. You don't see anything rushing past you, and you probably never even thought about it. But if Earth suddenly decided to stop spinning, just for 1 second, would you feel it? What would actually happen? Well, spoiler alert, that would be catastrophic. So, who started the Earth's spin in the first place? And why hasn't it stopped spinning after 4.5 billion years? Let's dive into it. Let's start with the obvious question. If Earth is spinning so fast, then why don't we feel a thing? Right now, if you're standing near the equator, you're moving at roughly 1040 miles per hour. Yet, your coffee stays in the cup, nothing feels unusual, and you're not struggling to stand upright. The reason is surprisingly simple. You only feel changes in speed, not constant motion. Think about flying on a commercial plane. Once it reaches cruising altitude, you can walk around, pour yourself a drink, or even balance a coin on the tray table. Everything inside the cabin moves together at exactly the same speed. You only notice movement when the plane accelerates, slows down, or hits turbulence. Earth works exactly the same way. The ground, the oceans, the atmosphere, even you, everything is rotating together at nearly the same speed. However, a plane has engines. Earth doesn't, which raises an even bigger question. Why hasn't it stopped spinning? Well, to answer that, we need to look back at the very beginning. Before Earth, before the Sun, before any planets existed, the matter that would eventually become our solar system was scattered throughout the Milky Way. Long before that, after the Big Bang, enormous clouds of hydrogen gas and cosmic dust slowly formed across the universe. Over millions of years, nearby material collided, merged together, and formed even larger clouds. Those countless collisions weren't perfectly straight. Everything bumped into everything else. Tiny random motions slowly gave these enormous clouds a slight spin. Eventually, enough material gathered in one region that gravity began taking over. Gravity pulled more and more matter inward. And as these gigantic spinning clouds collapsed, something strange happened. Imagine water flowing toward a drain. The water doesn't move perfectly straight inward. Tiny imperfections and collisions cause the water to begin swirling. Once a small amount of rotation appears, more and more water joins that same motion, eventually creating a large spinning vortex. The early solar system behaved in a similar way. As gravity pulled billions of tons of gas and dust inward, tiny random motions and countless collisions gradually combined into one dominant direction of spin. Almost everything in our solar system inherited that spin. The planets spin, the sun spins, even many moons spin. But then something bizarre happened. As gravity squeezed this enormous cloud into a much smaller Earth, instead of slowing down, the spin became faster. But why? The answer lies in one of the most important rules in physics: the conservation of angular momentum. Sounds complicated, but you've probably already seen it. Imagine a figure skater spinning with their arms stretched outward. They're rotating, but fairly slowly. The moment they pull their arms close to their body, they suddenly become a blur. Nothing pushed them, nothing added extra energy. Their mass simply moved closer to the center. The young Earth did exactly the same thing. As gravity compressed billions of miles of gas and dust into one rocky planet, its rotation naturally sped up. And because space is almost a perfect vacuum, there's almost nothing to slow it down. In theory, Earth could keep spinning forever. Except it isn't. Someone has actually been quietly pressing the brakes this entire time. Believe it or not, the moon is slowly stealing Earth's rotational energy. Its gravity constantly pulls on Earth's oceans, creating tides. But because Earth spins much faster than the moon orbits, those tidal bulges don't stay perfectly lined up. They get dragged slightly ahead, and the tiny mismatch creates friction. Think of it like trying to slow down a fully loaded semi truck while using a bicycle brake pad. It's incredibly weak, but the braking force is there. Earth slows down by about 1.7 milliseconds every century. It doesn't sound much, but over millions and billions of years, it becomes quite noticeable. During the age of the dinosaurs, a day lasted only about 23 hours. And more than 1 billion years ago, a full day lasted only 18 hours. In fact, every birthday you've ever celebrated happened on an Earth spinning ever so slightly slower than the year before. So, what happens if the brakes eventually win? Let's imagine the impossible. If Earth suddenly stops spinning, believe it or not, everything above the surface would actually still keep spinning. The oceans, the atmosphere, and you would all continue moving at over 1040 miles per hour. Near the equator, the atmosphere would continue racing around the planet at supersonic speed. The resulting winds would flatten cities. Forests would vanish, entire oceans would surge across the continents. Even if Earth slowed down gradually over billions of years, life would still become almost unrecognizable. Without Earth's rotation, the ocean would slowly migrate toward the poles. Huge regions around the equator would become dry land. Meanwhile, one day would last an entire year, 6 months of relentless sunlight, followed by 6 months of freezing darkness. But thankfully, none of this is going to happen anytime soon. The moon's break-in effect is incredibly small. Long before Earth ever stops spinning, the sun itself will have reached the end of its life, which means the spin we're experiencing today is a surviving relic from the violent birth of our solar system over 4.5 billion years ago. Since its formation, Earth has completed more than 16 billion rotations. Every sunrise, every sunset isn't really the sun moving across the sky, it's you, standing on a planet that's been spinning continuously since before life even existed. And it gets even crazier. Right now, you're standing on a planet spinning at over 1,000 miles per hour, orbiting the sun at 67,000 miles per hour, while our entire solar system is racing around the Milky Way at over 500,000 miles per hour. And somehow, your coffee still stays perfectly in the cup. The next time life feels like it's standing still, just remember, you're already flying through the universe faster than you ever imagined.